Hi, my name is Kazuyuki Motohashi. I'm a professor of technology management in the University of Tokyo. So in this video, I'd like to explain science economy innovation strategy in the 21st century. So this chart is describing the big concept of a science economy, but the economy started from manual economy, which are based on the human being power. The next, type of economy is industrial economy, and this started from 19th to 20th century. So which when the industrial revolution happened in Europe and the US. Here is a scalability in physical production is very important because at the manual economy, human beings use their power to produce something, but in the industrial economy, they gain the power from steam or electricity, which makes the one human could do, is drastically, improved. And so, but recently, we can see something like science revolution happen in the 21st century. So beginning of year 2000, there is, there is a finding of a human genome code or internet, commercial use of internet started in the late 20th century, but after 2000, this accelerated the rate of the diffusion of the internet in the business. Recently, machine learning, AI, big data analysis, IoT, so those things is coming. So those, so-called science revolution, that will change the mode of the economy from physical-based industrial economy to scalability of the knowledge production, which is intangible. So this actually concept of the science economy is I proposed in my book, which is about 5 years ago, published by Nikkei. So this book is basically talking about what is innovation strategy in the 21st century, given that there is a big change of the environment when we're talking about innovation after 21st century. Okay, so I'd like to start with the actually big range of economic progress of these 10 countries. First you look at UK, Spain, US, those Western countries, and I'm measuring the economic progress by GDP per capita, so which is the per person value added they generate. So something like how much one person could do to add to the economy in terms of the US dollar sense. And you can see that late 18th century, beginning of 18th century to the, so there is a pick up of this, GDP per capita in UK, Spain, US. So basically, so this is I already talked about. They shifted from manual economy to the industrial economy by the use of steam engine or electricity instead of individual human being. So those power makes the volume which could be managed by the one human being at a factory, for example, improve a lot. So this is basically the reason why their per capita GDP picked up. And the same things happened in Japan in late 19th century, so when Meiji Restoration started. So Japan imported eagerly about the Western technology, make use of this the fruit of industrial revolution, as well as they are investing in a physical infrastructure like electricity, utility grid, and railways, those transportation services, and Korea, Brazil, Taiwan, Egypt, they are following the trend, and recently China, India, so they are catching up. So the point that the difference in terms of the stage of economic development in this 10 countries across time. It's just, I would say, that the matter of the timing when they started shifting from manual economy to industrial economy. But of course, the developed economy like Japan is worried about is of course the catching up of late comers like China and India based on cheap factor price like labor cost or capital cost. So what is a new mode of innovation? How you could change from industrial revolution. So where we are going. So this is basically the point which I propose science economy. I just recap about what I briefly explained at the beginning, that manual economy changed to industrial economy, and so here scalability in physical production is very important, and so physical infrastructure such as electricity, railways. So those are the very important infra which are the basis of scalability. And here, innovation is taking place inside individual company. And the new, wave of economy, which is science economy, which happened based on like a science revolution in the 21st century, as I talked to you, like a genome, coding, internet, nanotech. So those are actually the benefited from scalability in intangible knowledge. And so the infrastructure which is important for this economy is more virtual, like internet, IoT. Not only these IT related technologies, but life science, nanotech, other scientific finding is the basis of the innovation. And the mode of innovation is changed from in-house to platform ecosystem of innovation. So let me discuss a little bit more detail about mode of innovation. And so for the left-hand side, which is the industrial economy, it's starting from technological discoveries, so which is basically built up by company, and company do some product innovation, and they produce, they invent new product, and then these products will goes into user society with process innovation, so which is technology for production of some particular type of products under the reasonable price with high quality. So those product and process innovation is basically taking place in one company. But for the science economy, the basis is not a proprietary technology inside a company, but you have to based on more like a public scientific discovery, because many scientific discovery which is found in academia, published freely in a paper, database, or those things could be shared with many others people. And so this is very broad. And then science innovation is taking place to come up with technological platform instead of just one product. So this is something like a combination of the product technology, and this platform makes the scalability of knowledge be available. And then those based on this platform, they could make some business innovation which is related to the users and society. So this business innovation is to form up some business model based on platform. And so in this science economy, of course, you cannot do this the whole range of the actually broad scope and also depth, because sometimes scientific discovery is very basic by your own company. So you need to form up the team, or I would say ecosystem, or open innovation. So which is a kind of keyword in a science economy era. Let me recap what what I discussed in a previous slide. So industrial economy versus science economy. So industrial economy, product process innovation, and the MOT, management of technology in this era, is basic idea is technology push or market pull. So there is a one technology and there is a one market and how to match. So this is very important for the management of the new product development process. And in Japanese, we call the monozukuri, so which is like a physical, production is very important, and creativity in the production is important. And the style is in-house development, business development. So this is basically, confined within one company. Science economy is based on science-based plus business innovation, and particularly for this business innovation, business system design is very important because it's not just selling the products, one products to the user, but you need to form up so-called business model based on platform. So this is called a kotozukuri in Japanese, so which is business model development. And the mode of innovation, open innovation is very important. And science-based, of course, it's based on a scientific finding. Scientific finding is coming out of university, public research institutions, those public entity for research. And so university and industry collaboration is very important. For the business innovation, many times your customer is company, it's not an individual, so B2B business. So in this case, collaboration with the customer is very important. Firm is very important. And if this your actually customer is individual people, like a B2C business, then you need to have like a platform, like internet platform, which could detect a big, size of information where you are actually whom those is used, the user which is using your products. So there is an example. I just this is something like a Japanese company example. One is Komatsu Construction Company, and they actually use IoT technology, which is called the iConstruction, using a big data of their construction machinery users. And then, so their business model is not just selling their products, but they are offering or providing construction services based on this, data. And Uniqlo is fast retail, which is kind of high-end textile, but reasonable price, textile innerwear, basically, producer. And plus Toray is Japanese kind of material company. So based on a science base, so Uniqlo have a big customer base, plus Toray has a technology, and they combine. So basically science base, Toray plus the business development by Uniqlo. So that will, come up with a big, the business. So out of there. So here is kind of example. And finally, I like to show that, what is a strategy, okay? So this picture is, you can see that in the bottom, there is the curved, region, which looks like a mouse, smiling mouse. And so this, I just, characterize this mouse is kind of academic, mainly academic, scientific knowledge in the world. Yeah, of course, there are some scientific knowledge in the industry, but so this is broad, and this progressing a lot. But the many cases, those are the very, very basic, which is very far from the industry, and so there is some arrow from this, the mouse toward the center, and you can see that there are small circles. So those are the science-based high-tech company, I mean startup company. So niche, so tech ventures. So and this is form up based on the academic finding. So university startup you're talking about is based on the university academic research, But because startup, they got a valuation, they got the investment from capital, or they have their customer for their your services. So those are the making some science innovation. And toward the center, you can see a big circle. So here is kind of big company operating at the end. So the top of this chart is basically final demand. And customer needs is becoming more dynamic, diverse, globalization taking place, and uncertain. So it's kind of broad. It change, and also you cannot detect the specific customer's demand precisely. So in this case, the big company like a business innovation provider, so which is basically B2C keystone company inside this ecosystem. So they have to serve together with many other company, other ecosystem to match to the changing and diverse and uncertain final demand. And there is another big circle below, which is a technology coordinator, which is a B2B keystone in also in ecosystem. So this is basically the global picture of the industrial organization of innovation in the science era. So first of all, so this B2C keystone to the final demand. So you need business innovation. So here ecosystem strategy is very important. And for the academia to the niche high tech ventures, or technology coordinator, so they are science innovation and co-evolution. So this is a new style of UI collaboration, in a sense that UI, university industry collaboration, used to be a linear model, so which is a university invent something and used by industry, but here is kind of co-evolving. So sometimes university itself doing the business as a spin-out company like a university startup. And finally, these two have to be orchestrated by policy, and sometimes national innovation system reform have to be taking place as a nation. Okay, so I have lots of research projects under the headline of these 3 points, and if you're interested in, come to my website, and I hope that I will release another presentation based on the one of the more detail of this point. That's all. Thank you for listening.